Welcome back everyone. We're going to be talking about Generation 2 cages for my Stryfe, Rapid Strike and Nerf guns versus the original Gen 1 I guess. So this is the Brushless Mod. Let's go shoot some random darts. Okay, so Generation 2 is a complete and utter redesign from the ground up, from the original one, red being original and black and white being the new one. None of it is based off of the original cage. Everything has been completely remade from the ground up. All the measurements were retaken because my feeling was that they weren't exactly correct the first time. So now alignment with the barrel is absolutely perfect and the alignment of everything is perfect. Starting off with one of the major changes is it has been significantly reinforced. You can see now that the bottom of the cage goes all the way around. This is much longer and higher and thicker, and we deal with one of the big problems with Gen 2. One of the problems we faced with Gen 1 is the fact that there was movement in here. Now that was originally intentional so you could fit the wheels in on an angle to get underneath this with the wheels on, but unfortunately what that created was a bit of a problem. The problem is that you screw your 3 screws on the bottom here, M3 or 3 millimeters, and that's what obviously gets screwed through the bottom of the cage, and that is what prevents the motors from obviously just breaking / moving away when you put the dart through. And there's actually a significant amount of force applied this way on the motors to bend them away. So the problem is that there's actually a very small amount of surface area. You've only got, I guess, roughly half the side of each of the screws that is preventing this from moving away. The other half would prevent it from moving in, but that's never very useful. Obviously the motor gets fairly warm and we've got it screwed into plastic, and the surface area is even smaller than you think, and that's because it's actually on the thread of the nut. And if we zoom in, old school zoom in, whoosh, there we go. The thread of the nut is actually what's touching the inside of the plastic. So as this gets warm and gets pushed against the plastic, obviously this is like a knife, it's going to just push into the plastic even without heating. Just with the pressure continually applied to this, it ends up meaning the motor slowly moves away, which means of course performance is reduced. So having the motors only retained on the screws was quite a bad idea. So in Gen 2 we have resolved that by encapsulating the motor. So what I mean by that is that now when we put this in here, the motor is now retained by this outer ring on the outside of the motor. Now what that means is that you don't need screws in theory, but definitely use the screws. But now we have significantly more meat holding the motor in, so to help prevent the deflection. Another big change is I've changed the motor wiring to come out the bottom of the cage instead of out of the front. It came out here and then out here and then around underneath here, which kind of made no sense. It also meant that I lost an awful lot of very important reinforcement because I had this hole through here which I can now use to hold the cage together. Now with that, in Gen 2, the way I originally did the wiring I wasn't very happy with. It worked, it was completely valid. I took everything and popped it out into here, and then I put the battery on top, which is certainly an option. However, with the Gen 2 rewire I changed it to the ECs underneath the motors, And then I have the Arduino down here, and the buck converter down here, and then well, the only thing that goes out here are the wires to the battery. We have improved the dart guide. This black one's actually longer than the white one. One of the problems I was having at one point, which resulted in very inconsistent and me really scratching my head with performance, is that it seemed to shoot better with a poorer magazine than my favorite magazine, which really did make me scratch my head. And that came down to the fact that the dart guide was fairly short and had a very square back, and the better the magazine, the more upwards pressure it pushed on it, which you got this kind of bend on the dart, and the back of the dart would actually sometimes catch on this hard end and end up kind of taking a gouge out of it, or more importantly kind of stopping it, and ends up in dart grinding. So I have improved that. I have changed the wheels, obviously, because I now have this little ridge, which is easy to see on the white one, to help retain the motor, which of course is not in properly. Oh, sorry, hopefully you don't get seasick there. Which means I had to go over that. So the bottom of the wheels have now got this bevel on it. Camphor is actually it. Or comfort, I'm not sure how you're supposed to say it. Which the original wheels didn't have, which means they don't fit the original wheels. I have added to the wheels, which will probably be almost impossible to see on here. You can 9.1. This is the original crush that I've always used, which is 9.1 millimeters, which sounds like not a lot, but since it's applying it to the entire side of the dart, it is. However, I realized that due to the inaccuracy of printing three-dimensionally, that some people's 9.1 might be someone else's 8.7 or could be 10.3 or whatever. So there are three different sizes I've put up there, and I've never used anything other than this, but we can play with different crushes. So that goes on there. Now I have got this funny little cutout along the top of the wheels, and that is because I've had to raise the motors. Now in the original one and in this one, the motor actually overhangs over here. Now I've had to raise that in Gen 2 because it turns out, and it was actually hard for me to, I didn't actually know this with Gen 1, which also has the motor overhanging, but it was actually touching the inside of the shell of the Stryfe. So that meant that the cage was sort of sitting on a bit of an angle, which of course affect the alignment of everything. So I've had to lift the motor 1 millimeter and then push the wheels down 1 millimeter, so the wheel center is still in the center. But that has meant that the inside of the wheel starts rubbing on the inside of the shell. Now there's the plastic that comes along here would rub on that. So I've had to take that off, so that's why we've got that step there, which you didn't need because it was 1 millimeter lower. Now there is one other important thing. I talked about how I had to raise these motors because it was running on the inside of this. Now this is the top, so it wasn't running on that. The bottom of this motor was pushing against that and preventing the alignment from being correct, and how I've had to raise it up 1 millimeter. The negative side of that is that unfortunately the top of the motor heads now run on the inside of the shell. Now you've got two options there. First is to just simply take about 2 millimeters off the end of the motor nuts, which is fine. You could just grind that down or whatever you want. Could potentially just run the motors and do it with a file. Some of you are about to scream, oh, but that's going to make it out of balance. Well, yeah, potentially it will. However, that is directly in the center of the axis, so any out of balance would have little impact. And we also need to remember that there is no way you can print these wheels and have them in balance. Well, maybe saying no way is too big of a thing, but I have never managed to print one that is perfectly in balance. Possibly once I get my $1 billion printer, I will be able to print them perfectly in balance, but that seems unlikely. So you can either cut the top off, or you can drill holes in the shell, which I haven't done either, so that's going to be an interesting one. The easiest way to get the hole alignment is to just put the shell on and push, and obviously fire it up, push it down, and it, of course, very conveniently gives you a few markers where you need to drill some holes. And then we need to make some kind of cover, which I haven't done yet, and really it should have a vent holes on this side. It blows quite a lot of air out, but of course the problem we have now is that how do we actually get the air out of the actual shell of the Stryfe and into the universe around us? It's fairly common to have something on the back, which I've done there's a version with vent holes which would be better than this, but really it's sucking the air in from that side. I kind of feel like it should actually be on this side blowing air out, but because we're so used to putting them on there, I guess maybe we should just run with the fact that that is better than nothing. Well, this does have holes around it, intentionally holes around it, so that is something to be aware of. But you can still make this mod without making any shell modifications if you want, and that is one of the cool things. You can go 100% stealth with this mod if you wanted to, because you don't need to make any shell modifications to fit this in, which I think is pretty amazing that we can get this kind of performance without any shell modifications at all, as long as you grind the top of those down. I've also changed the vent hole significantly on the Gen 2. There's less of them, only by one I believe, but they're much larger to increase cooling, and they're actually on a taper. So the inside down here is smaller than the diameter out here, which helps to create a bit of a vacuum. The reason for this is because a lot of people have problems actually doing up the wheels. There again, for the inaccuracies of 3D printing, sometimes you couldn't actually do up this nut because you couldn't hold the motor. You can hold the bottom of the motor, but that's not connected to the top, so you could never do up this nut on the top. So there was a dual idea by changing those vent holes. If I can do this up, why do I always grab the counterclockwise one? We can now stick a screwdriver or a 3mm screw or whatever down the slots, okay? And that, putting that down that hole, will lock. That comes down and goes into that vent hole, which means you can then hit the inside of that vent, which means you can lock it together and then you can do it up. Now, even if you don't need to do that, you need to make sure that when you do put the wheels on, that they do actually align with the vent holes. I've also actually changed the angle of these vent holes. These actually angle out, and that's because the motor naturally has a centrifugal force throwing the air out like a turbo. Now, originally I actually didn't angle them out. I angled them in if we're talking about this one here, on an angle like that. Now, like a propeller, really. Now, that was all good and nice, except one rotates clockwise and one rotates counterclockwise. So that meant for one of the wheels it was sucking the air out, and for one of the wheels it was pushing the air in, which would be fine, except for the motor naturally sucks the motor out, so the one that's trying to blow the air in was really fighting it. So now we have just run with the natural centrifugal force of the motor and just got them both sucking out, so it doesn't really matter. So that's the different wheels. One other huge change that I have made, that I have not made on either of these two but I have in here, is that when firing poor quality darts, sometimes you would get a mega jam, where the dart would come in and kind of go around here, and the entire thing would end up getting sucked down here and around. Now I prevented that in two ways. One way, in the original one, I actually have a greater space here. And that was basically because I was afraid of the top of the wheel grinding against that. And so I thought I'd just have a bigger gap. So that's been removed, which of course reduces the size of the gap and the chance of it going in. I have, however, changed how this works here. So the problem is, and I guess it can happen through shooting banana darts, ones that are to start with, or low quality darts where the heads aren't stuck on properly and it gets more grip on one wheel or the other, and it ends up actually shooting it not straight through the cage. And as soon as that happens, it's a disaster. So I've taken this corner here and pulled it well out to here and put a taper on it, which you can't see in this particular white one. It's on the black one because this is an older version of the cage. So that means that if it doesn't go directly through the dart, through the cage, it doesn't get caught on this real sharp edge and jam. There's now a tapered edge which should deflect it back in. And the same goes for this edge over here. We've now tapered all of that. So if the dart doesn't go directly through, it can course correct it to some degree. And hopefully that will resolve all of those issues. If not, we'll have to go to Gen 3, and that is going to be a serious pain. Also on this version, which is different to this, is that this has been extended. Now, done that for accuracy, but the main reason for that is because I had to cut this back for this angle that I'm talking about, for the tapering in. I mean, that actually shortened the barrel length to like 4mm or something, which I didn't think would be particularly good for the old accuracy, so I had to add that back on the front. So that's pretty much Gen 2. It's a complete and utter rebuild. Nothing is the same as the original one. It should be significantly better, and it should be, hopefully, the end of this, as in not requiring any significant changes after that. It certainly is. I'll never be able to view that. Oh yeah, perfectly aligned if you accept the fact it's out of focus. So that is Gen 2. If you have a prior version, get rid of it and print a new one. Another change that has been made thanks to the community is that sometimes it felt like the motors were damaged. It would normally happen after this massive jam where when you pulled them they would now not start at the same speed, so you get quite a bit of torque. It was most noticeable on the slowdown where one would stop well before the other motor. And that, interestingly enough, was actually in the EECs reprogramming themselves all the time. So there is that a point at which it starts and the point at which it stops. Now, for whatever reason, it reprograms those points, which means they get out of sync with each other. So I have updated the code for the EECs, so flashed them with the new one, and that prevented the motors from getting out of sync, which shouldn't happen because they're connected to the same Arduino, but, or whatever, Trevor. Yeah, you can obviously get this all from my free download from Thingiverse, where this is all maintained. Pop us a like if you like. Pop us a like if you don't like anyway, because I have spent truly insane amounts of time on this doing Gen 1. I've done a billion different versions of this, and I've done a billion different versions of Gen 2, and I've done billions of wheels. And in the background, the annoying noise is the printer printing more stuff. But I've done this for you guys because, well, because it's fun, really, isn't it? Because nerfing is fun when you can shoot at 200 feet per second. Yeah! Alright guys, see you later. Bye bye.